Hello, today we're going to be talking about the Pythagorean Theorem and the different ways you can use it to solve problems. Before we talk about the Pythagorean Theorem, let's first talk about what it means to be squared. And I'm going to do a distance of 3. If I square that, we all know that 3 squared is 9. So how did we get that? Well, 3 squared, we literally took 3 and we made a square from it. So remember, a square looks like this. So if you notice, it's 3 across and 3 down, and we just finish off that square. And if we counted up all the blocks inside, there would be 9. But let's take the opposite of squaring and let's talk about square rooting. I have an amount of 3 squared, 9, right? And if I arrange that in a perfect square, what is the side length of that square? Let's take 3 squared, right? 9 little blocks. Let's arrange them in a square. And let's look and see, well, what does one side of that square equal? Instead of the square root of 9, maybe they ask for the square root of 10. Well, the square root of 10, if I take 10 blocks, it's going to be bigger than 3 by 3. So I'm going to take that extra block, right, because there's 9 blocks. I'm going to take that last little block, and I'm going to kind of chop it up and just kind of put it along this edge, a little tiny bit right there, and along this edge as well. So it's going to be just bigger than a 3 by 3. Kind of hard to see, but you can see that it's just bigger. And that's why the square root of 10 is not 3, it's 3 point something. Because look here, 3, and then a little tiny piece or point something of the next square. It's important to understand that square rooting is kind of the opposite of squaring. So to undo a square, you would take the square root, just like when you think, division is the opposite of multiplication or subtraction is the opposite of addition. So let's talk about the Pythagorean Theorem. The Pythagorean Theorem is pretty cool because what it does is it's saying if we have any box, let's do a 4 by, so what was that, 6? Sure, okay, a 4 by 6 box here. It can find the length between here and here. Now in class we did that thing where we actually drew out the squares and chopped them up and moved them around and things so that you could see that the Pythagorean theorem is true. For this lesson, we're just going to assume that we understand and know that the Pythagorean theorem is true. So we know that a squared plus b squared equals c squared. So what this allows us to do is find the diagonal measurement of any rectangle. That rectangle could be a square, that rectangle could be a very long and skinny rectangle, short and fat rectangle, doesn't really matter. Remember, with a rectangle, we always have right angles here, and this is technically a right angle as well. So then we say A here, B there. Yes, this would also be A, and that would also be B, okay? But this diagonal would be C. Anytime you need to know the diagonal from one corner of a rectangle to the opposite corner of the rectangle, you can use the Pythagorean theorem. The Pythagorean theorem can also be used anytime you have any right triangle at all, okay? So any right triangle like this one here, and it doesn't really matter. I typically always take that the shorter side is A and the longer side is B. But remember, right, commutative property allows you to add them in any order. So it doesn't matter which one you say is A and which one you say is B. The important one to remember is C. So always, always, always make sure that you label your hypotenuse, right, the one across from the right angle, as C. As long as that one's correct, the rest of it will be. Now in class, we've used the Pythagorean theorem with cones. Do you remember having to find the volume of a cone? Well, sometimes when they give you a cone, they'll give you this length here, the side of the cone. What you need for the volume formula is you need the height of the cone. So knowing this, well, look here. That's not A, that's not B. That would be the hypotenuse because here is the right angle. So you have height, or B, right? And you have the radius, A, and then the side of the cone, that is C. So if they give you C and they give you the radius, A, then you can figure out the height, because that would be the B there. And then you could use that height or that B measurement. So where else are you going to use the Pythagorean theorem? Sometimes they will give you a coordinate plane. So here's my coordinate plane with my y and my x-axis. And sometimes they'll just give you 2 points. They'll give you a point here and a point here. And they'll say, what is the distance between these 2 points? So the Pythagorean theorem is basically the distance formula, or how they derived the distance formula. So you take these 2 points, and do you remember slope, right? With slope, you had to find the rise and run between the 2 points. It's very similar to that. You're going to find the rise difference and the run difference. So basically what I've done is I've made a right triangle here. So I have an A length, I have a B length, and remember, I'm trying to find the distance between these two, the C length there. So A squared plus B squared is going to be C squared. Let's go ahead and do some of these for real. Actually, we'll just go ahead and do this one right here, since I drew it really nicely on a coordinate plane. So the first thing is we always write our formula. Okay, A squared plus B squared equals C squared. Let's find out the length of A. So 1, 2, 3, 4, 5. So 5 squared plus 1, 2, 3, 4, 5 equals C squared. So 5 squared, now you do need to have your squares memorized. If you do not have your squares memorized, you need to start working on that. You can make a Quizlet. I have one for my students already created. They could just join my Quizlet class and practice with digital flashcards. But there's nothing like just having a set of flashcards and that you can just go through over and over and over again, okay? It's like the multiplication tables. You just have to have them memorized. Yes, if you have a calculator, you could just type it in there, but right, it is something that you should just know, and it'll make homework go faster. It will make things easier to comprehend when the teacher talks about them. Start getting those memorized. So 5 squared is 25 plus 25 equals C squared. 25 plus 25, of course, is 50 equals C squared. And now we need to just have the length C. So we need to undo or do the opposite of that square. So come back up here. Remember, how did we get the opposite here? Finish that up there. So to unsquare something, you have to take the square root. So we're going to take the square root of 50, which is going to equal the square root of C squared. Because remember, whatever we do to one side, we have to do to the other side. And as long as we do it, as long as we do it to both sides of the equation, we're keeping the equation equal. So on this side, we will get C. And now, if they want it exact without approximating, we need to go through and we need to reduce this. So let's think if there's anything that we can to reduce it, okay? Now, we know it's the addition of 25 and 25. So we could multiply 25 times 2, and that will get us 50. So the square root of 25 times the square root of 2. Now we can solve the square root of 25. We know that that is 5, and we could multiply that by the square root of 2 to get C. If they want an exact and they want a simplified radical, which of course they do, right? Just like simplified fractions are just expected, this is what you would give. 50 is really close to 49, and we know the square root of 49, right? So this is just a little bit bigger. You could take the calculator. Now here, square root of 50, look, it reduced it for us. It has this little button that will change it into a decimal. So if you notice, remember the square root of 49 was 7, so the square root of 50 should be just a little bit bigger than 7. And if we look here, it is. If they're going to have you give the approximation, oftentimes they'll have you do it to the 10th or 100th place. So we're going to go ahead and go to the 100th place. So we'd put 7.07. So, or I would say C is about 7.07. If you want to just check to see if that really is true, we can take the corner here, and I'm going to line up. I get just a little bit more than 7 across. So here's 1, 2, 3, 4, 5, 6, 7, and the teeniest, tiniest little bit of the next one. It's always good to kind of mentally think, does that make sense? If we have a 5 by 5, the hypotenuse has to be larger. My suggestion is to go through your textbook and practice using the Pythagorean theorem with the examples they have there. Remember, some of the answers are in the back of the textbook, so you can check to make sure that you are getting them correct. If there's any in there that are not in the back of your textbook, you can always bring them to me, and I will check to see if your answers are correct. Alrighty, thank you.